No, what are you doing, man?
I'm simulating the Doppler effect with the paper airplane.
Oh, really? What's Doppler? I don't know what's Doppler, but what I can tell from what you're doing, it feels like you're moving really fast, even though you're just really moving really slow. You feel like you're moving the speed of fighter planes of U.S. Army. Do you know what I mean?
Yeah, it's because of the sound I'm making with my mouth.
But why is it feels like you're moving real fast?
I bet that you get these types of sounds as something's approaching you, and these types of sounds as it's moving away. Say you have a little bug.
I don't own a bug, okay, but
and this whiteboard is like a pond,
okay.
like a bunch of water. And
Can
when
I
the
own
bug
the-
moves, it's got a little ripple around it. And this is all just water. If he's
Like
moving
that.
toward you
And making a sound.
and moving the water,
Okay.
he will, every next one will be a little closer to you. So it'll start the most past one, and then a more recent one, even more recent, more than that. He'd be getting closer to you.
Yes, this.
And in the same way, sound is like these little waves, where here it has a high frequency, and here has a low frequency. So what do you think, dude?
No, it feels like logical. It makes sense, but
Right?
can we test it with real world experiment? Like in a real physicist who
Well-
has a PhD.
I'll tell you what. I made this buzzer, and it's basically just a little speaker that'll make one sound. I wonder if we can record it making a different sound moving toward the camera
And
than it would moving away from the camera.
Okay, 2Ks and see if there's any difference between the pitch
True.
and frequency of the sound. Hero, can you hear that
I
difference?
did hear it, dude. It's pretty
I wasn't
cool.
expecting it's true, man. And I take a look on the web. I just learned that in order to find out what
What sound you hear?
sound I'm going to hear, I just have to time the
What it's
frequency that's
actually
actually
making?
making
Yeah.
and time it with the distribution. So this is the
Just the speed of sound.
speed of the sound.
I see.
And this is the speed the body is moving. So let's say you're moving towards me, and then I just put this minus sign, and when you're turning away from me, I put the plus sign, and as a
I
result,
see.
I can calculate what sound I'm going to hear on this planet.
You know, I bet we can figure out how they got this
Can you
equation.
do this? I can't do it.
I bet we can.
Really?
You have this formula, that the speed is equal to the frequency times the wavelength. If we rearrange this, we get one of these, that the frequency is equal to the velocity divided by the wavelength. And I think if we take a closer look at this and rewrite one of them so that we can have that the wavelength for the observed is equal to the velocity plus or minus the velocity of the object divided by the frequency, we can take this and then plug it back into there to get the equation that you showed us before.
So we just proved it, man. So we know why when somebody is traveling toward us, it sounds like producing high pitch, and also we learned that when it's traveling away from us, why it's making lower pitch sound. And we even come up with the
Good job, bro.
question. I'm happy.
Me too.
Shall we learn more about
So,
science?
no, let's get out of here.